This is part 2 of the binomial theorem lesson. We were just talking about how to find the binomial coefficient, which is read n above r. And I was telling you could use this in your calculator, so let me pull that up and show you the button. If you go to math, and then you go over to probability, the third one down is NCR. Now, the tricky thing is you have to plug in the first number first before you go to NCR. So for example, in part A here, I know I already have the answers, but that's okay. You can still do them. We do 6 first, then we go to math, probability, NCR. It's actually read N, choose R. Then plug in 2. So 6, choose 2, and we get 15. And then the next one's 3, choose 0, so 3, math, probability, NCR, 0. And then we do 9, math, probability, 3. Oh, sorry, I pushed the wrong button. Try that again. 9, math, probability. Here we go. Choose 3. We get 84. And then the last one, 4, math, probability, NCR, 4. And we get 1. So that's how we find the coefficient. Now you need to be careful as to what n and r mean. Okay, n is your coefficient, like we talked, your exponent, like we talked about before. So if it's a plus b to the n, this is the same n right here. Okay, those are the same thing. It's your main exponent. And then r, you can either think of it as the term number minus 1, or you can think of it as the exponent on b. Personally, it's easier for me to remember the first one. R is the term minus 1. So here's what I mean. We actually start with 0 when we look at it. Let me back up and show you an example. So for example here, this would be 3, choose 0. This would be 3, choose 1. This would be 3, choose 2. This would be 3, choose 3. So that's why we start at 0, so we end with the same number we have on top. So 3, choose 0 is right here. 3, choose 1. 3, choose 2. And then 3, choose 3. So you can see our term is actually 1 bigger than r. If you'd rather remember that, the term is r plus 1. This is the thing is r is the term minus 1. So 0 is the first term, 2 is the 0 is the first term, 1 is the second term, and so on. Okay, so let's apply this and actually expand this using the binomial theorem. Now you could do this using the old algebra rules where you would just FOIL over and over and over and over. But that takes a long time. Now I know this may feel like it's long, but compared to having to FOIL and simplify, it's actually not all that bad. So let's just start with our coefficients. We would have 4, choose 0, plus 4, choose 1, plus 4, choose 2. I'll just go ahead and go to the next line. Plus 4, choose 3, plus 4, choose 4. And I know once the numbers match, I've gone far enough. And again, you should have one more term than your n, or your exponent. So our exponent's 4, we should have 5 terms. So that's right. Now I take my a, my first term, and I start it with an exponent of 4, because that's what my exponent is here. And then I go down 1 each time. And we'll be simplifying in a minute, so don't worry about any of that yet. So then we take our b, and we start it with 0, and we go up 1 each time. Okay, now we can use our calculator to solve for the coefficients for us, and then we'll be able to simplify. So we're doing 4, choose 0. Tell you what, one thing that'll save you some time, if you notice I've already got 4, choose 4. So I'm just going to hit second enter. That pulls up the same thing, and all I have to do is rewrite the 0. So I get a 1, and then 4, hit second enter. I can just change the 0 to a 1. I get 4. And I change the 1 to a 2, and I get 6. So let me go, I think we can remember this, 1, 4, 6, and then we go 4, choose 3, whoops, we get 4, so 1, 4, 6, 4, and then the last one should be 1. The first and last one should always be 1. So 1, 4, 6, 4, 1. That's the pattern. It'll always be symmetrical if that helps you remember. So I know this is going to be 1, 4, 6, 4, 1. So my first term is 1 times x to the 4th times 2 to the 0. 2 to the 0 is just 1, so it's just going to be x to the 4th. Plus 4 times x cubed times 2, because 2 to the 1st is 2, plus 6 times x squared times 2 squared is 4, plus 4 times x times 2 cubed is 8, plus 1 times x to the 0, that just goes away, times 2 to the 4th is 16. So now I just simplify those coefficients and I'll have my final answer. X to the 4th plus 8x cubed plus 24x squared plus 32x plus 16. And that is how we use the binomial theorem. Okay, so let's try this with a few more. 2x minus y to the 5th. Okay, so my a is 2x and my b is negative y. And that's important. Make sure you keep the negative with it. So let's start with the coefficients. 5, choose 0. 5, choose 1. 5, choose 2. 5, choose 3. 5, choose 4. 5, choose 5. Then I start with my a, which in this case is 2x. I start it with the biggest exponent, which is 5, and I work my way down by 1 each time. And then I take my b, which in this case is negative y. I start it at 0 and work my way up. Okay, now we can simplify each one of these. Alright, for the sake of time, I'm hoping now you know how to plug the coefficients in the calculator, so I'm just going to do those. 5 choose 0 is 1. Now 2x to the 5th, you have to raise both the x and the 2 to the 5th power, so it becomes 32x to the 5th, and then negative y to the 0 is just 1. Plus 5 choose 1 is 5. 2x to the 4th, so you have to raise the 2 and the x to the 4th power, so you get 16x to the 4th, and negative y to the 1st is just negative y. 5 choose 2 is 10. 2x cubed is 8x cubed. 2 cubed is 8, x cubed is x cubed. Now negative y squared, the squared cancels out the negative, so it's really just y squared. Okay, and then 5 choose 3 is also 10. 2x squared is 4x squared. Remember, square the 2 and the x. Negative y cubed stays negative. Cubed keeps the negative. 5 choose 4 is 5. 2x. And then to the 4th gets rid of that negative, so it's just y to the 4th. 5 choose 5 is 1. 2x to the 0 is 1. And then negative y to the 5th keeps the negative sign. Just remember that even exponents always stay positive. Odd exponents keep the sign. So we finally get down here. To simplify this all the way, we get 32x to the 5th plus, let's see, 5 times 16. And actually, let me back up. I'm going to make that a minus because of this negative right here. So that negative makes it minus 5 times 16 is 80, x to the 4th, plus 10 times 8 is also 80, x cubed, oh, excuse me, let me back up, I'm very sorry. Our first term is good. Our second term, I forgot my y, don't forget that. I brought the negative out front, but I still have to put the y. And then 80 x cubed y squared. And then I have a minus here I'm going to bring out front. 10 times 4 is 40, x squared y cubed. 5 times 2 is 10x y to the fourth, and then finally we have minus y to the fifth. And that covers the entire thing. Whew. Alright, last thing you need to know how to do is just find a single term, because sometimes you may only need to find one term out of the whole thing instead of finding the entire thing, which is good, but it's good to practice how to do that. Okay, so we want the fourth term of 3x plus 2y to the seventh. So you got to think through this carefully. Fourth term is going to be 7 choose 3. 7 choose 3. Because 0 goes with the first term, 1 goes with the second term, 2 goes with the third, so 3 will go with the fourth. Okay, and then a, we got to think about what a, that's our 3x, is going to be raised to. Well, it started at 7. We're going to the fourth term. So 1, 2, 3, 4. So it's going to be raised to the fourth power. And then our b, 2y, is going to be raised to the third power. If you remember, r is always going to match the exponent of b. And in fact, one way you can figure it out, if you don't want to write it over to the side like I did here for the a, you know that these two should always match, and these two should always add up to n. They should add up to the total. So if you just put this one in for the b, and then figure out what plus that gives you 7, that's another way you can handle it. Okay, so let's find 7 choose 3 in the calculator. 7 math probability 3 gives us 35. Okay, 3 to the fourth is 81, and 2 cubed is 8. So now we have to do 35 times 81 times 8. We get 22,680 x to the fourth y cubed. And that would be the fourth term in that series. Okay, if you need practice, I would suggest looking around these pages. This was the homework I assigned this particular time, but if you need practice, anything around those numbers would be a good idea.